Okay, so I'm going to do some clarification about the binomial approximation to the normal curve. So we're going to do this example here so you can see exactly how this problem works. So the Denver Post stated that 80% of all new products introduced in grocery stores fail or are taken off the market within 2 years. If a grocery store chain introduces 66 new products, what is the probability that within 2 years, then we have a set number, and there is a typo here. So we do have a set number of things. So because it is a binomial, either they fail or they don't fail, we do have some formulas that we have to use. So we'll have to figure out what mu is, which is n times p, and then we'll have to figure out what sigma is, which is n times p times q, and the square root of that. So if we notice, the probability of fail is 80%. So I'm going to move this. So it's 80% or 0.8, which happens to be our p on this, on the first one, because we're still talking about fail. That means q, which is our probability of they don't fail, which would be 0.2. And then n, if you look up here, they introduced 66 new products. So our n is 66. So we can find our mu and our standard deviation, and we will need those to be able to do these problems. So the first two, like I said, are fail, and then the last two are succeed. So we'll talk about how you do the opposite when you have two different problems of each one. But let's go ahead and find mu. So mu in our case is going to be 66 times 0.8. And if I pull the calculator over, 66 times 0.8 is going to be 52.8. And then we're going to find sigma, which will be n times p times q, and the square root of that. So once again, we would type all that in the calculator. So the square root of n times p times q, which that answer is going to be 3.2496. And I'm going to round that to 4 decimals because I know eventually my z-scores will be rounded to 2. Okay, so the probability that 47 or more will fail. Now if you recall, on binomial probabilities, we have our r, which is our number of successes. Well, in this case, success is failure. So we're going to say our success is 47 or more. And we have that chart that we got yesterday or the day before, I can't remember which day I did that, that talked about what to do when you have the greater than less than, because you do have to do continuity corrections. So let's see if I can pull up that chart real fast. So I'm going to see if you can see this. So we have this chart right here that talks about what do we do when we have that. And so you'll have to refer to your notes if you have that somewhere, which you should. But if not, pause it right now and write this down, because that's kind of a key essential when you do continuity corrections. So we're going to be utilizing that. Okay, so coming back down here, if we have r is greater than or equal to 47, we can refer to our chart, and it does say subtract 0.5 from the number. So 47 minus 0.5 would be 46.5. And that is now our x value. So we've changed our discrete variable into a continuous variable. And that is what I can change to a z value using my mean and my standard deviation. So to do that on my calculator, I'm going to do 46.5 minus 52.8. And then I'm going to take that answer and divide it by that 3.2496. So I get negative 1.94 if I round that to the nearest hundredth, which I'll want to do. So I'll have the probability that z is greater than or equal to negative 1.94. So once I have that, then I'm going to go over into my z table. So I'm going to pick this up and pull that in here. So let's see if I can have multiple things showing. So I want z is greater than negative 1.94. So I'm either going to do 1 minus that. So I'll look up negative 1.94. So 0, 1, 2, 3, 4. So this 0.0262. So on here, I'm going to do 1 minus 0.0262. So if I do that, 0.0262, I will end up with 0.9738, which means there's a 97.38% chance of this happening. And that would be my answer for this one. Okay, now I am going to show you, I could have looked up a positive 1.94. 1, 2, 3, 4, right there. And 9738, hey, that's the exact same number we got. So if you have greater than, you can look up the opposite numbers. Okay, so let's just get these set up, because I think once we find the z-scores, you should be able to find those probabilities. So here we've got 58 or fewer. So once again, that's at our R. So we've got 58 or fewer. So that includes 58. And once again, using this chart right here. So we have R is less than, so we're going to add 0.5 to the number. So 58 plus 0.5, I'm going to have X is less than or equal to 58.5. And then I'll convert that to a z-score. And I'll use these same numbers over here to convert that to a z-score. So 58.5 minus 52.8, and then divide by 3.2496, and I get 1.75. So 1.75, since it is less than, I'll just look this number up, and that will be my answer. So, but let's go down and talk about these where I have succeed. Well, if you recall, this is our mu, our average for failure, so let's find our mu for succeed. So our mu for succeed, I still have 66 possibilities, but now my probability of a product succeeding is 20%. So I'm going to find a whole new mu here because it makes it a little bit easier than trying to think of it backwards. So it'll be 13.2. And then my sigma, it actually doesn't change at all. And the reason is because if you think back to these original numbers, none of these numbers changed. We just flip-flop these two around, and multiplication is commutative, so it doesn't really matter. Okay, so now for success, I want to use this. So once again, so here we got the probability of 15 or more. So R is greater than or equal to 15. So coming back to that original chart to change my R to an X. So when R is greater than or equal to, I subtract a half, which makes this 14.5. And then I can convert that to a Z. So I'll do 14.5 minus 13.2, which is my new mu, divided by 3.2496. So I get 0.40. So 0.40. And then I'll find the Z value. So since it's greater than, I'd either subtract from 1 or look up the opposite. And then here on my final one, fewer than 10. That means R is just less than 10. So that is not including 10. So that gives us a different one. So if R is less than a number, not equal to, just less than, we're going to subtract 0.5 from the number. So that means to change it to a continuous variable, subtracting 0.5 makes this 9.5. And then I'll have to convert that to a Z again. So 9.5 minus 13.2. I divide that by 3.2496. And I get a negative 1.14. And once again, I would look all these up in my table. That one's a less than, so I would just look it up exactly as is. So negative 1.14 would end up being 1270 or 12.71%. And then here, I'll go and look this one up. So the opposite of 0.4, I'm going to look up negative 0.4, which would be 0.3446 or 34.46%. And while we're looking things up, let's go ahead and look up a positive 1.75, and that will be 0.9599. or 95.99%. So I hope this clarified the binomial approximate to the normal curve, and hopefully you understand a little better about what it is that these kind of questions are asking you to do. Good luck!